Chapter 23, Example 1. Resting pulse rates for a random sample of 26 smokers has a mean of 80 beats per minute and a standard deviation of 5 beats per minute. Among 32 randomly chosen non-smokers, the mean and standard deviation were 74 and 6 beats per minute. Both sets of data were roughly symmetric and had no outliers. Is there evidence of a difference in mean pulse rate between the smokers? How big? So is there a difference is asking us to do a hypothesis test. How big means we'll do a confidence interval at the end. Since these groups are independent, there's no reason to think the smokers impact the non-smokers. We have two groups. Let mu n be the mean pulse rate of non-smokers. Let mu s be the mean pulse rate of smokers. The hypothesis will be that H naught mu s minus mu of n, the difference between the pulse rate of smokers and non-smokers, equals 0, which means that there is no difference. The alternative, HA, is that mu s minus mu n does not equal 0, that there is a difference. The question didn't ask us, is one slower or faster than the other? It just said, is there a difference? So let's check the conditions. I have random samples and 26 smokers and 32 non-smokers are both fewer than 10% of their respective populations. I am told the data are approximately normal. It is reasonable to assume the smokers and non-smokers are independent of each other. Since the conditions are met, I will use a student's t-model for a two-sample t-test. Let's write down what we know, then we'll use the calculator to find the p-value. So n of s, the sample size of the smokers, was 26. N, the sample size for the non-smokers, was 32. The mean for the smokers was 80 beats per minute. And the mean pulse rate for non-smokers was 74 beats per minute. The standard deviation of our sample of smokers was 5 beats per minute. And for non-smokers, we had 6 beats per minute. So let's go to the handheld, go to New Document, Statistics, Stat Tests, and now we're going to do a two-sample t-test. We're doing it from statistics, not data in the calculator. So we're going to type in x1 is 80, standard deviation is 5, sample size 26. For non-smokers, we have 74, 6 for the standard deviation, and a sample size of 32. Mu1 not equal to mu2, that matches up with our alternative. Do not do pooled. We will never do pooled with means. Don't worry about it. So there's all our data. We're going to have to scroll up a little bit to see that t-value. You can see right there, alternative, that's what we're going with. Our t-value is 4.15. P-value is 0.000113. We have 55.95 degrees of freedom. You don't want to find the degrees of freedom by hand. Use the technology. So degrees of freedom is 56. T with 56 degrees of freedom is 4.45. Our p-value is 0.00011. And let's take a look at the curve real quick. Since our alternative is mu s minus mu n does not equal 0, we're doing two-tailed, so we're shading on both sides there. My p-value, 0.00011, is very low. So I will reject the null hypothesis. There is evidence to suggest there is a difference in the mean pulse rate of smokers and non-smokers. Now, it also said how much of a difference is there. So we're going to go to the calculator again. We're going to do a confidence interval. We're doing a two-sample interval, again from the statistics. We're going to type in the same stuff we have in our box there. So 80 for the mean, 5 for the standard deviation, 26 for the sample size. For the non-smokers, we have 74 for the mean heart rate, 6 for the standard deviation, and 32 for the sample size. Hit OK, 95% confidence interval, no pooling, never do pooling with means. We scroll up a little bit, we have a lot of that information already. We might want to write down our ME, but we're mainly concerned here on the 3.106 and the 8.893. These are upper and lower bounds. The tens place is good enough for this. For heart rates, we're probably not looking for hundreds or thousandths of a beat. I am 95% confident the mean pulse rate of smokers is between 3.1 and 8.9 beats per minute. Faster than that of non-smokers.